Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now. Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
So, hi everyone, my name is Sumit Verma and I am a mentor at GFG. And currently, I am pursuing IT from Delhi Technological University. And today, we'll be seeing the live mock interview. And today, we have with us Mohd Mawan Ahmad.
So hi everyone,
How are you, Mohd?
I am fine. How about you, sir?
I'm really good. So, let us first let us first start by introducing yourself.
Okay. So my name is Mohd Mawan Ahmad. I am a third year undergrad at Graphicra Hill University. From couple of months, I am doing DSA, and I have solved around 500 to 600 questions on LeetCode plus GFG. I have
Mhm.
also ranked eighth in the campus at GFG, and
That's really
three
good.
star at 3 star at LeetCode. I have also done a internship in Android development for Bhumi Computers for 6 months. That's
Mhm.
it.
That is really nice. So, tell me something briefly about your intern. How was your experience? What all have you did there?
So it was a nice thing. Bhumi Computers is a company who just takes the project from the freelancers and give to their employees. So I was one of the intern, and I worked on a food delivery application. For that,
Mhm.
I implemented the payment gateway side and design patterns of this of that application. And one another project come in the couple of months was a food was e-commerce application. For that, I designed the whole UI of that and implemented. I also wrote the backend in PHP. The backend was in PHP. I wrote the APIs for that, and that's it. That's was the experience. It was great, by the way.
I must say that is a lot of work. So you have mentioned in your resume a word that is REST API. So can
Yes.
you tell us something about that?
Yeah, API is application programming interface. Actually, when we have front end and back end, so we
Hmm.
don't have anything from which a front end can communicate to back end or back end can communicate to front end. So for that
Hmm.
communication part, APIs are used. So if my front end application needs some information from the back end, so what I'll do, I'll just fire a API and ask the backend so that give me that data, and backend in response to that will give me some data in a JSON format or XML, whatever, and then the front end will parse it and accordingly update the UI. So this is the primary work. Or in case we are just uploading any data, then also that post APIs are used, and for just getting the data, get APIs are used.
Yes, that's a nice brief.
Mm.
And about your personal projects, you have mentioned three of them.
Yes.
So can you tell me something briefly about the C++ learning app that you have mentioned?
So yeah, it was my first application which I deployed on the Play Store when I was learning the Android development.
Hmm.
I deployed it when I was in my 12th class. And so it was a very basic application in which a user can easily learn C++ from video tutorials or the text which I have written there. So I have
Hmm.
integrated Firebase real-time database also, so that in case if a user want to know that how much he have covered the syllabus of the application, so that he can know from the progress tab. So in that I was using a database for fetching that yes, this user has read this document, then updating the backend, and that's how I was updating the progress bar of the users.
Okay. So can you tell me all of the languages that you know at this time?
Mm. At this time, I have comfortable hands in Java, and I also know C++ and Python, but I'm not that much comfortable in these both languages, but more
So
comfortable in Java.
basically, you will be doing the DSA in Java today.
Yep, sure.
Okay, that's good. And what's your proficiency in DSA
In DSA, I can say I am about 5 to 6 about on a
out
rating
of
of
10?
10. Yeah,
Okay,
5 to
okay.
6.
Yeah, that's good enough for today.
Mm.
So I guess you have the link for the doc.
Yes, I have the link.
So please open it and share your screen.
Okay. Is my screen visible?
Hmm, not now, but yes, now it is visible.
Okay.
So yeah, here you can see your very first problem. And the
Mm.
first problem
Okay.
is the nth number made from the prime digits. So you have the digits allocated to you that are 2, 3, 5, and 7, because that are the only single
Okay.
digit prime numbers that we have. And you are given a
Okay.
number n, and
Okay.
your task is to find the nth number, which can be made using only these digits. So basically,
Okay.
if you consider the sequence, that is 2, 5, so sorry, 2, 3, 5, 7, up to
Mm.
37, like this.
Mm.
Then you have to tell the nth number out of this sequence. So you get the problem.
Yeah, I got the problem. Okay.
Okay.
So let us find the
So
nth number.
first, let us discuss the approach for this problem. So what will be your approach?
Okay. May I have any other test case for this?
Okay. So basically, in this example, you are given n as 10. That means you have to
Okay.
give the 10th number of this sequence. The first number is
Okay.
2, the second number is
Okay.
3, and then
Okay.
5, and then 7, and the 10th number that is present in this sequence is 33. That is why
Okay.
the
Okay.
output is 33. So
Mm.
now is this clear?
Yeah. Now it's clear. Okay.
So say
So.
if I give you n is equals to 4, then the output will
Mm.
be
Okay. If n is equals to 4, the output will be 7.
yes.
Okay. So one brute force solution is this: we can iterate to all the elements, and first of all, we will check that whether the current number has all the digits which are in 2, 3, 5, 7, and
Okay,
we'll
okay.
check and then return accordingly. But it will take
So
a lot
what
of
will be
time,
the
I
time
think.
complexity of that approach?
In that case, time complexity,
So basically you are
we can't
taking
even
each and every
count.
number
Yes,
from 1
yeah,
to n.
yeah.
Okay. So the time complexity
And
will be,
time complexity in this case,
and basically you will be taking each and every number from 1 to n, and then
yeah,
checking whether all of the digits of that number
whether all of the
are
digits
2, 3,
are in
5, or
2, 3,
7.
5, 7. So time
Okay.
complexity for checking will be O of n for every number, but we are traversing from 2 to the number until we find the nth number, so it
Yes.
can be very large.
Yes, yes.
So
So
I
it will
don't think
be
it's a great idea.
in the order of that number. That will be the output.
Yeah, yeah,
So that is
yeah.
a very large number. That can be a
That
very
will be
large
a
number.
very large number. That can be a very large
Yes.
number.
So let us
So
discuss something optimized.
yes, yes, sure. So we can do one thing. We can just use a BFS here to find
Yes,
out the
yes.
numbers.
BFS will be the best
Mhm.
algorithm. in
Hmm.
this case.
Suppose we have this two. I can write now. Suppose
Yes,
we
yes.
have 2, 3, 5, and 7. So what I'm thinking is I will just insert these all numbers into the queue,
Mhm.
I'll just run the BFS, and I'll just take out this element first, and I'll check. I'll just increment the counter and check whether the counter is equivalent to n or not. And if it is not, then I'll just insert the next number of it, and the next number of it will be 23. No, it
No,
will be
no, that
22.
will be
Wait,
22.
wait, wait.
Yes.
Yeah, it will be 22. It will be 22, and then it will
Mhm.
push 23, 25, and 27 into the queue. And same goes
Yes.
for when 3 will be popped out. It will push 32, uh,
Yes, yes.
33, 35, and 37. And this how the work. This will be the flow of the program. And in this
I
case,
think this much is enough.
mm, the time
So,
complexity will be of n only, because we are iterating only n elements, not more than
yes,
that.
yes. And the
Mm.
moment you get that number to be generated, even
Yes.
before getting it into the queue, you will
Yeah.
just return that as an answer.
Yes, yes, yes. We'll just return the answer.
So,
So
yes.
is
So,
my approach correct?
yes, yes, your approach is correct.
Okay.
And there's a link provided there, and
Hmm.
you can click that to get to the problem, and
Okay.
then you have to code that.
Okay. Sure. So should I start to code?
Yes, yes, you can start.
First of all, I need a queue. So the numbers can be in a very big range also. So I should take it in long only. Now I need to push 1, 3, 5, and 7. So here I am pushing all the elements 1, 3, 5, 7 into the queue, and now I am just maintaining a counter. That's 0. Now I'll just run this loop while queue is not empty. I'll just pop out my number from here. Now I'll increase my counter. If my counter is equivalent to n, then I'll just return this number. If it is not the case, then I'll push all the numbers which can be made out of this digit. So offer number n plus. It will be 2.
Yes.
5, 7. Sorry. 2, 3, 5, 7. Yes. Yes, I think it should work now.
Yeah. So before just submitting the problem,
Yes.
can you tell something is missing here? So can you spot that?
Okay. Replaced. Okay. Offer.
Actually, the very
Count.
first mistake that is here is the variable name is counter, not count. So first update
Okay.
that.
Okay. Yeah. 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 Sorry. 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 Yes. Here also.
Yeah.
Any other mistake?
Now I think everything is good. Now you can try compile and run
Okay.
this code.
It's a compilation error. Okay. So I need to just typecast it into long. Hope it should work now. This again a type. Okay. So answer is expected to be an integer only. So I don't need to know. I don't need to use
Yeah.
long here.
In the very first thing,
Yeah.
you are expected to use the q of integer,
Hmm.
but that's also fine.
Change it. Because, again, it's a compilation error. Okay, current number. So it is an integer.
Because the
Okay.
current num is long.
Hmm.
Now that's
So,
working.
yep. So should I submit it?
Yes, yes.
Okay. Okay. So it's done.
So can you actually make some little changes here to make the to just uh, prevent doing some more operations, because there are few operations that are being happening here, that
Hmm.
you can't
Redundant
actually.
code you are trying to say.
Yes, yes.
Mhm. And we delete it. So it's and commented here. And same
So
goes.
that for
So
loop is not actually the optimal thing, because it starts from 2 and then the next number will be 4 and the next
oh
number will be
yes, 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 yes,
6.
yes.
Yes.
Sorry. 2, 3, 5,
That can
7,
be
8.
left as it is there.
Mm-hmm. Okay.
Actually, what you can do here is you can have a array list of elements 2, 3,
Yes,
5,
yes,
and
yes,
7,
yeah, yes.
and then
We
in
can
the
do
while
that.
loop
In the while
you
loop, we
get the
can run
idea.
through that. Yes, I got that.
Yes.
Fine. Hmm. Tempo 5 please will be. Not
Yes, now everything is totally fine.
okay.
Now try to submit this code again.
Okay. It's a compilation error. Okay. Sorry. My bad. It's taking more time than usual. Should I refresh the page? It's taking more time than usual.
Mm, First copy the code and then refresh the page, just in case the code
Okay.
gets deleted.
Get that. Hmm. Okay. It, it is still here. It's
So
working fine.
now I think it's working. Yeah.
Hmm.
So just submit this code and then we'll move on to the next problem.
Yeah, sure. Yep.
Yeah,
Done.
that's really good. So now let us move on to the next problem.
Okay.
So the next problem is on the next page.
Okay.
The problem name is
Oh,
good subtrees.
okay.
So you are basically given a root node of a binary tree, and each node
Hmm.
of the binary tree is assigned a value. And you are
Hmm.
also given an integer k,
Hmm.
and you have to return the count of good subtrees. In the definition of good subtrees is stated here that the good subtree is a subtree that has the number of distinct values in the subtree, each of them are either less than k or equals to k. So if a subtree is having all the elements in it that are less than or equals to k, then
Hmm.
that subtree will be a good subtree.
Okay.
And a note is
Okay. If
also provided here. Yeah. What was your problem?
no, 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 I am trying to understand that you are given a root node of a binary search tree. Binary assigned as well. Okay, so let me just write a test case here. So
Yes.
suppose this is a tree
Yes.
and the value of k is 5 here. Value of k is 5 here.
Yes.
So,
Yes.
for this node, this is inside the case value. So this will be counted as a good subtree, and the same goes
Mhm.
for 4 also. It will also be counted as a good subtree, but 6
Yes.
and 7 will not be counted as a good subtree. So due
Yes.
to these two nodes, this 5 will also not be counted as a good subtree. But
Yeah.
this 4 will,
Because it's
yeah,
yes. Yes.
but this 4 will be counted as a good subtree. So
Yes.
totally, one, two, three. Only three good subtrees will be there.
Yeah. That's the correct answer for this test case. So now
Okay.
try to think of a algorithm to solve this
Okay.
problem.
Okay. So what we can do? We can just do our DFS here and just check whether the node is inside the value of k or not. If it is inside the value of k, we can just return true to its parent and
Hmm.
update the count value. In this
Yeah.
manner,
That's
we will
the
be.
right direction. You're going in the correct direction.
Mhm. So I think in by using a DFS, we can easily solve this question. Uh, mm, if for any node, if it's left child or right child, if any of the two returns false, then the particular node can also not be a good subtree. So it will also return
Mhm.
false from there. So I
So
think this will
the
work.
thing that you're telling me is actually
Yes.
an algorithm to tell whether a particular subtree is a good subtree or not. Okay,
Yeah.
so
But we
basically you're
can.
telling me that if left
Yeah.
subtree of a particular node is a good
Yeah.
subtree and the right
Yeah.
subtree of a particular node is also a good subtree,
Is also good.
and
Okay.
that node that you are on right now is
Yeah.
less than or equals to k, then the
then
entire subtree
then the
is
entire
also a
subtree
good
will
subtree.
good, and then we will
Yes.
update its and when then we will update
Yeah.
the answer variable, which will be a global or a reference variable.
Yes, yes. So you can actually take a global variable and
Yeah, yeah.
then it just keep on increasing the number of counts.
Number of counts, yes.
Yes.
So that's what I was thinking about.
Yeah, you can just go ahead and implement that.
Okay, sure. So I think it's a question of weekly interview series.
Yeah. Yeah, that's the second
So,
problem.
oh, second one. Actually, this question is already done. Shit.
You can just remove your previous code. Yes.
But I think the question which I understood is a different question.
Okay, why do you think so?
Okay, let me read this one also. You are uh, given a root node of a binary tree, and each node of a binary tree assigned a value. You are also given an integer k. You have to return the count of good subtree in the binary. Number of distinct values. Here it is distinct values, and the question which we are having, that which we are on, is that a good subtree will be that tree in which all the nodes have the value less than or equal to k.
Yes, and the subtree is having distinct values here also.
Okay, it's k distinct values. Okay, okay. So then I have to just change my approach. Actually, the approach that actually I thought that in this question I have what I have to tell whether if a tree has all its values inside k is inside k. If all the values
Hmm.
lie inside k, then it is a good subtree. But actually, the
Yes.
question says that all the values that are distinct should be in k. Distinct value
Yeah,
should be in
that
k.
must be distinct also.
Number of distinct values. They are saying number of distinct values should be in k. Okay, so in this case, I'll use a map here, map or set here.
Yeah, you can
So,
use that. Yes.
so in this case, what I'll do, the approach will be same only. I'll do a DFS here and just update the value into the set, and then I'll check whether my set's value is less than or equal to k or not. If it is less than or equal to k, then I'll return true to its parent, and if it is not, then I'll return false to its parent. So if a node's left and right child both returning true, then we have to just take all the values from its left child and right child's sets and make a new set, and then insert the value of the current node, and then check whether the size of it is smaller than or not, and then return true or false accordingly. I think
Yeah,
there is
that's the
a
correct approach.
miscommunication. I think there is a miscommunication between the question or something wrong.
Yeah, there is. I do also think so.
Sorry, your voice is shattering. What you said?
I also do think so.
Hello, your
Hello.
voice is shattering, sir. Yeah, now it's audible.
Yeah, I said that I do also think so. That the problem is not clear. The problem
Mm.
statement is not clear itself.
Sir, actually, your voice is not audible.
Hello.
Hello, is it audible now?
Hello. Hello. Am I
Hello,
audible? You are
not
audible
clearly,
to me.
not that much audible.
I'm saying that you are audible to me.
Sir, actually, I'm not able to understand what you are trying to say. Your voice is not audible.
Hello.
Hello,
Am I audible
is
now?
no, no, not hello.
Hello.
So should I quote this one problem statement or the weekly this one question?
Yeah, that one.
This one,
This one, yes.
okay, okay, sure. So may I start my implementation?
Yes, yes. You can start your implementation.
Okay, 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 that's fine. Okay, so what I have to do? I have to do a DFS and insert the values into the set, and then check the values are in the range of k or not, and then return true and false accordingly. Okay, so I can just have global variable answer as 0, and I need to create a class node here. It's,
I think the
it's
class node has already been created.
hello. Uh,
Hello.
so your voice is not audible that much.
Am I now audible?
No, not clearly.
Hello,
Hello,
Mohammed. Am I audible?
hello.
Yeah. Give me a second. You can
No,
rejoin
ma'am.
us.
Your voice is shattering a lot, ma'am.
There is a connectivity issue from your side, Mohammed.
Hello, hello,
Hello.
hello, hello.
You can rejoin the meet, please.
Ma'am, your voice is not audible. Okay, rejoin the session. Okay, got it.
Okay, till then I'll be reading the chats. So actually we were both audible to everyone.
Audience.
Yeah. Hello?
Yeah,
Hello Mawan, I'm audible to you.
yeah. Now you're perfectly audible.
Okay, I think there was a connection issue from your side because we both
Maybe
were audible to the audience.
might happen. Might be possible.
Someone is saying use your mic, it was much clearer. Okay, okay. I'll do the same. So am I audible?
Yeah, now you're audible perfectly.
Is it much clearer?
Now, yeah, yeah. Now it's much clearer.
Yeah. Thanks Tanmay for suggesting that. Okay. So we can continue coding the problem.
Yeah,
Yeah,
yeah.
you can
Sure,
share your
sure.
screen once again.
Yeah, sure. So is it visible?
Yes, yes.
So this is though this was the question. So you were telling something.
Yeah, I was telling that I think the class node has already been defined. You can see the definition
Wait,
by
let me check the
clicking
driver
there.
code.
Yes.
Yes, yes, yes. The class node is already been defined. Okay, so I can make any another node. Refresh the page. Okay, so I can just name it as temporary node. We need to have name, so which can tell me whether the left child or right child is true or false, whether it's into the conditions or not. So
Hmm.
let me name it as is possible, and I need to have a hash set so that I can just take out the values from the left child and right child and then create a new hash set and then check whether the values are in the range of k or not. So I
Okay,
need a
okay.
hash set here. So I can name it as math also.
So till the time you're doing the coding part, Can I tell something to the viewers?
Yeah, sure.
So actually, all the viewers, this problem is from the interview series 73. So GFG is also conducting some interview series every Sunday, and you can take participate in that. Uh, Only three problems will be there. Uh, Problem one, two, and three, and in the increasing difficulty order. And this is the second difficulty order of the second problem from the contest 73. And I think 76 contests have been conducted. And one more fact to be shared with you is that me, uh, I am actually a Discord moderator for interview series. I do daily discussions for the interview series problems on Discord also. So you can join the GFG Discord problem, and we can have a chit chat and some problem discussions there on a daily basis. So how many of you actually perform uh, s- these problems, interview series problems? How many of you do regularly solve these problems? You can write +1 in the chat.
Okay, I can just do.
So Devanshi Gupta is regularly solving. Yeah, I remember her. Yeah, Prashant Pawar. Oh, just in the journey has written -1. Buddy, just start doing that thing. You can join the Discord channel and you can start the discussion there. Rohit Bhatt is saying +1.
What? No.
Actually, Devanshi Gupta is a regular problem solver there. You can see her solving daily problems. She provides the algorithm, she discusses the codes and all that. Yeah, that's a really good thing.
It, uh,
I'll share the Discord channel link shortly. So Arima is saying that I have started recently solving and participating on regular basis. Also trying problem of the day. I'm only able to solve one problem in every series. Yeah, that's fine for the start. That's really good. What are now active there? Yes, yes. It's really good thing to be active on a Discord channel like GFG. Many of the discussions are being conducted there. Not only coding but also other things like DBMS, OS, and other dev things, daily problems, interview series, and all that. You'll find very good material there to discuss. Devanshi Gupta is saying thank you. Oh, that's my pleasure.
so if current map dot size is less than equals to b, okay, I'll just with true and it's so okay. I need to update the answer also. You can value headset. If we will call this, it will get to the left and right. It will return me back. Okay. I think it should work now. So, so I think I have done the code. Can you please have a look at it?
Yeah, I think that's fairly good. You can try to compile and run this code.
Okay. Okay. So okay, it should be a static class and it should be a
Static int.
okay. Return statement is missing in 113. In line number 139. Okay. If
Basically, the
else.
function's return
Okay. Okay.
type
Okay.
is, yeah.
Okay. Got it. It should return the answer. Where the redundant code is. Okay. So expected output is 4. I think something is not correct. Let me just check once more. Okay, static temp get node. If root is equals to null, return temp true with new hash set. Then we will give a call to left subtree, and then we'll get a call to right subtree, and just make a new map from the left and right. If any of this is false, then we will just return then we will just return from here and not count this node. Otherwise we will just add all the elements to the current map, and afterwards we are checking that whether the size of the map is less than or equal to k. If it is, then the answer should be updated, and then I am returning this temporary node to its parent. So it is going
Hmm.
wrong.
There might be some small mistake here.
Yes, there is some small mistake only. Mm, left dot map, right dot map. Temporary answer. Okay. Current. Okay. False. So it's supposed to be useless. Not able to find out what's happening in this
Hmm.
code. Why it is going wrong.
So what I can actually see here that your approach is absolutely correct. Only some small mistake is there that is left to be found. But I think we can just move on to the next problem for now.
Okay.
If we
Okay.
get enough time, then we'll return to this problem.
Okay.
So
Sure.
I think you should jump on to the next problem.
Okay. Sure.
So the next problem is on the next page.
Okay.
Yeah. Next problem's name is count total set bits. So you
Okay.
are given a number n, and you have to find the total count of set bits of all the numbers from 1 to n. So basically you have to you have to check each and every number from 1 to n, and then
Hmm.
count the number of set bits in that number, and then
Okay.
just sum up for all the n numbers from 1 to n, and then that will be
Okay.
your answer. Like for n is equals to 4, the numbers will
Okay.
be 1, 2, 3,
One,
and
two,
4,
three.
and the
Okay.
count of set bits will be 1, 1, 2, and 1, and their sum is 5. So that is the answer for this test case. So I think you get the problem.
Yes, I got the problem. So,
Yeah.
so one brute force solution which is coming to my mind is we can just run a loop from one to n and just manually count the bits, how many bits are there, and just return back the
Mhm.
answer. So it
Yes,
will.
yes.
So first of all,
Yeah,
we have to traverse. It will take O of n time, and then we have to check every bit, and it will also take O of n time. So it will go around O of n square approach.
yeah. But that is
But
not the most optimized approach here. Yeah. Can we
one
think
more
of something better?
Yes, one more approach which is coming to my mind is we can count set bits in log n also. That how many set bits are there in a number. So in this case, our complexity will be reduced to n log n if we are able to
Yes, yes.
find the set bits in log n time.
But I think that's not a huge advantage here.
Okay,
So if you want something, some kind of hint or some kind of direction, then I can give you that.
okay. Wait, let me think for this thing. Okay, so for number five, this will be 1, 0, and 1. Okay, 6. This will be 1, 1, and 0. Okay. So if we look from upwards, look there, can I get any hint for this question?
Yeah, yeah. So I have something interesting for you here.
Yes.
Is I will be giving you an observation, okay?
Okay.
And then you, by using that observation, you have to solve this problem. So the
Yeah.
observation that I'll be sharing is this: that if you consider all of the 3-bit binary numbers, then that will be
Okay.
like from 000, 001, 010, 011, then
Hmm.
again the same thing with one being followed in the front.
Yes.
Okay.
One being
Now,
followed.
can you notice one thing, that the answer for this is pretty trivial. For like you can notice that since this, number of total number of digits that can be formed by changing each of the bits here will be obviously equals to 2 into 2 into 2. That is 2 to the power 3. And that number
Great.
will always be an even number for any number of bits. Okay.
Mhm.
Do you agree with
Yes.
that?
Yes. Yes. I
And
agree.
you also know that for even set of numbers, you have equally even and equally odd numbers. Okay.
Yes. Yes.
Like for from 0 to from 0 to 7, there will be same number of even numbers and same number of odd numbers. So that means half of the numbers will be having the 0 bit in the last position, and half of the
Hmm.
number will be having 1 bit in the last position. So
Yes.
in
Yes.
this case, the let me say that m is the total number of bits that are present in this case. Okay. So m is the total number
Yes.
of bits. So now the So now you can say the number of times we are getting 1 as the last bit
Yes. Yes.
in this case will be
Hmm.
equals to 2 to the power m minus 1. So is
Yes.
this obvious for you?
Yes. Yes.
Because
I
basically
can.
the total number of digits that we can form is 2 to the power m, and then dividing it by 2 will be having 2 to the power m minus 1 numbers.
Okay.
Okay. So one observation that I can give you is that for each and every bit here, this information is true. That means for the first bit you can observe that again half of the numbers will be having 1 bit, and half
Hmm.
of the number will be having 0 bit.
0 bit.
So again for the third bit, sorry, for the second bit, you can again see that half of the numbers will be having 1 at
1,
this bit position, and half of the numbers will be having 0 at this bit
0
position.
position. Yes,
So
yes.
if I ask you the solution for the case when the number is actually 2 to the power, uh, when the n is actually 2 to the power x minus 1. Okay, so like in
Okay.
this case, the n is 7. So you are
Hmm.
taking all the numbers from 0, 1, 2, up to 7. For this
Yes.
specific case, the answer is simply 2 to the power m minus 1 into m, because we are having m bits, and
Hmm.
the sum for each bit position is 2 to the power m minus 1. That is the occurrence of that bit 1. Okay. So this
Okay.
specific for this specific case, the observation is that you will get your answer by this expression. Okay. So now can you use this information to actually solve this problem? Now just think for
Okay.
like 5 to 6 minutes, then I'll give you the second observation to further go
Hmm.
ahead with the problem.
Yes, that's true. Okay. 1 to 4. 0, 1, 0, 1, 0, 1. Okay. So if I select this number, it will be having three number of set bits. 1, 0, 1, 2, 3, 4, 5, 6. So it's an even number. So it's a bit. Okay. 5, 6. Okay. So it will have three. If it is an odd number, suppose it is an odd number, we having three only. It's even. Okay. If my number, if my bit is this, if I'm searching for a second bit, okay. So okay, I can just this thing. I can just divide this thing by 4. 1, 2, 3, 4, 5, 6. Okay, these two set bits. Okay, so let me just get more tests. See if it happens. Okay, one. Okay, if my number is this 1, 0, 1, 2, 3, 4. Okay, one thing I have observed here.
Yes.
Hello, is I'm audible? So I can just get to know whether on a how many bits are on for this number or not. We can just divide the number by if I am at the first bit. So
Okay.
if I want to know how many bits are on till this number, so I can just divide it by 2, and yeah, we can divide it by 2, and the quotient will be there. So will be the number of bits that we'll be having. And if I am at second bit, so I can just divide this by 4, and I can just get to know how many bits are on.
Yeah.
No, no,
But
no, sorry, 2. Here it will be for 2.
isn't that just reiterating the same thing that I have said?
No, I will just go to a number. Suppose the number is 4 here. So what I'll
Okay.
do, I'll just make a bit array of this. So 1 will be placed as, So when we place like this, so I can go to the first bit. uh, okay, it's a fourth
Okay.
number.
Yeah.
So I can just divide this 4 by 2 and get the number of bits of this first bit, so it will be 2.
Mm,
And
okay.
when I get to this second bit, I can just divide this number 4 by 4 and just get the number of bits.
But that's not true in this case because the number of
That's
bits
not.
that have been set are equals to 2, and according to you, it should have been equals to 1.
Yes, 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 it's not true for every case.
So let me just give you another hint or some
Okay.
sort of direction. So basically, you have got this trivial case in your hand.
Hmm.
The solution for the
Okay.
trivial case is already been provided to you.
Hmm.
Now you have to think in a recursive manner how to use this solution in a recursive manner to solve this problem. Okay, so let us assume that you are having an n whose bit representation is this.
Okay.
Okay, this is an very odd number,
Hmm. Yes.
actually an odd number and also a very odd looking number.
Okay.
So you can actually observe here one thing, that you have to consider all of the numbers. This number is having how many bits? 1 2 3 4 and 3 7. 1 2
7
3.
bits.
So that is 5 6 and 7. Okay, so you have to consider all of the numbers ranging from this number up to this number.
Okay.
Okay, and that's not an easy job, you can notice here. But what
Yes.
you can think here is, if you just ignore this MSB, then all
Okay.
of the numbers that are ranging from 6 bits, 6 bit 0
Yes.
and 6 bit 1 have to be
Hmm.
considered. Okay, because that are
Yes. Yes.
also part of this range, you know
Yes. Yes.
that.
Yes.
So the solution for this has already been provided to you. That is exactly
Hmm.
this. You
Hmm.
just have to put m is equals to 6 and you'll get this
Hmm.
answer. Okay. So
Hmm.
you have to just try to think of a way to use this result, okay, to solve this entire problem. So now basically you have considered all of the numbers where the MSB value is 0. Okay. So say you are
Okay.
having these many bit positions, 1 2 3 4 5 6 and then 7, and you're considering this bit position to be 0 at all the times, and
Okay.
you are considering these bit positions to be either 1 or 0 each and every possible possibilities, you are getting that.
Hmm.
And for
Yes.
that result, for that case, the result will be provided to you, that is this.
Hmm.
Now you
Okay.
have to consider of the case only when this bit is 1. Now this case is much is left, only this much case is left. Okay, so
Okay.
now think of the way to get this result when this bit is 1, because when
Okay.
this bit is 0 you have already got your result. When this bit
Okay.
is 1, you have to think of a way to get the result. Now once again, I'll give you one small hint also, that if you put all of these bits as 0 for now, that are 6 zeros, okay, yeah, that are 6 zeros. Okay, if you put all of these bits as 0 and all of these bits as the bits that are already provided in the problem, then
Hmm.
all of the numbers that are ranging from this, starting from this range and then ending at this number,
Okay.
okay,
Okay.
all of these numbers will be having 1 at the MSB position, and any of the numbers that are not lying in this range are not having 1 as their
One in
MSB.
the MSB.
Yeah, so now you try to use this also. So basically, I'm giving you the frequency of 1 being as at the MSB, and that frequency is actually the size of this range, which is equals to what? Try to think. What is the size of this range?
Okay.
So what is the way to generate this range? You'll basically
So we
put
can
this
just
0 as 1,
yeah.
and then put this 0 at 1 as 1,
Yeah.
and then put this at 0 again. So basically
Yeah.
counting from
Yeah.
00000 to 001101,
Yeah.
and
Yeah.
that counting is actually equals to what? It is
That
actually equals
that
to the, yes,
that will
yes.
be equal to 2 raised to power n, the number of bits.
No, no, no. From all of the zeros to this. That's that range. That range will be, if you think harder, that range will be actually equals to the decimal value of this part. Isn't that true? From 0000000 to 001101. You are iterating to each and every number. You're creating each and every number by flipping the bits in the trivial way.
Okay.
So that range will be actually equals to the decimal representation of this number plus 1, because we are also considering the 0. Okay, this case.
Okay.
So is that logical?
Mm, it is logical, but I'm not able to get the approach here.
What are you saying?
I was saying I was not able to get the approach. I'm not able to get the approach for this question.
Okay, so you get this much part. Okay,
Mm.
and now I'm telling you to set this bit as 0, and then
Mm.
after
Okay.
you set this bit as 0, then all of the numbers that can be formed will be less than or equals to n. Okay, that is true,
Okay.
because if
Yes.
you set the MSB as 0 and flipping each and every bit from 000 up to 111, then all of the
Yes.
number will be lying in the
Numbers will
required
be,
range,
yes.
and for that range you get the answer. That is this. Now only the case is left when the MSB is 1, and when the MSB is 1, all of the possible numbers that can be generated is this range. Okay,
Okay. Yes. Yes.
now the frequency of 1 is actually equals to the size of this range. Okay,
Okay.
so till now you have got these many set bits. Now you will be adding how many set bits, that is equals to the frequency of this MSB, that is the size of
Okay.
this range. Okay, size of the range that will be computed by you.
Mhm.
And then the left part is the numbers that can be generated using
Yeah.
this number only. So the numbers that can be generated when you are considering this range,
Mm.
when your n is equals to this, that means reiterating the problem. So
Okay.
you have to solve for this new n. So let me say it n dash, then the function call for n dash. So now let me clarify that one more time. You'll get this part. Okay, you got this part.
Mm. Yes, I got this part.
Did you got this part?
Size of the range not that much clear.
Okay, so if we so the can you can you tell me one thing, that if I set this MSB, then what all
Mm.
numbers can be generated?
If you set this MSB, then all the numbers, there will be many numbers will be then that can be
Yeah,
generated
but
by
that
flipping
number,
zeros to one.
but that number will never be having any one set bit at this position. You agree with me? You agree?
Yeah.
Do you agree with me
Yes.
at this
Yes.
point?
Yes. I agree. Yes.
That number will never be having a set bit at this position again, because
Yes.
that number will be generating a number that is bigger than n, and we don't
Yes.
want
Yes.
that. So
We don't
basically
don't want
we
that.
all, yeah, we all we know is that we want to generate all the numbers that are ranging from this binary representation up to this binary representation.
Yes. Yes.
Okay, is this logical?
Yeah. Okay. Yes. So
Is this
this
making
one bit.
sense?
So this one bit can should not also be set, because otherwise the
No,
number
no.
will be.
Yeah. That is true. That is
Mm,
true. This bit
mm,
should not also be set at any point of
set.
time. But if
Otherwise
I
the number will be.
unset this bit, then
Yeah.
I
Yeah.
can
If
set that bit.
then I
Okay.
can set. Yeah. Yeah.
Yeah.
Sure.
Because that number will be lying in the range. Okay.
Mm.
So now the
Yes.
problem that we are facing is that if we get to know the size of this range, okay.
Mm.
So let me ask you a simpler problem: 000 to 010. Can you tell me the size of this range? What is the
Size
size
of
of this
this
range? How many numbers are present in this range from 000 up to 010?
zero, three numbers are there.
Yeah, why three numbers are there? Because you are taking the decimal representation of this number and then adding
Mm.
one to it. Okay,
Yes.
the same
Yes.
thing I'm asking here. What is the size of this range?
So I'll take a decimal representation of this and add 1 to this.
Yeah, but in the previous problem, the initial number was equals to 000, and not,
Hmm.
if I ask you this 100 up to, sorry, 110, then again the answer is 3,
Hmm.
because you're
Yes.
basically taking this number, subtracting it with this number, and then adding 1.
Adding 1,
Now, do you
yes.
get the idea?
Yes,
Yeah.
yes.
So you'll take this number, subtract it from this number, and then add it to 1. So
Okay.
that will be the size of the range. So what
Okay,
we can
okay,
write
got it.
here is the size of the range. That is our
So,
current number n, and then
and my
subtracting what, 1,
n dash
sorry, 2 to
1,
the power the MSB.
yes,
Because 2 to the power MSB will be representing this, and then adding 1 to it.
1 to 8. Yes.
So
Got it.
yeah, that much part is clear. Now, what all numbers have been left to be considered? Basically,
So we can generate these numbers recursively.
yeah, have we considered all of the count of set bits that has been occurred at these positions? No, we have only considered the occurrence of MSB
Yes,
here,
yes,
the occurrence of one set bit at the MSB position. But we haven't
yes.
considered the count of set bits that
Set
have
bits
been
of
occurred
these
at these
positions.
positions while going
Correct.
from this number to this
So this
number.
one.
And
Yes,
I'm
yes.
only highlighting these 4 positions because I already know that these 2 bits will never get set.
They never
Okay.
get set. Yes.
So that's why if we just remove these 3 bits here from the
Hmm.
problem itself,
Hmm.
then the problem is boiled down to a new problem.
Hmm. How
And
many
that
set
problem
bits?
is actually a reiteration of the same problem that we're facing from the
Same
beginning.
problem. Yes.
So that's why I've written recalling of the function from n dash. So actually, this is the one line solution of this problem, where
Hmm.
this m is representing the number of
Hmm.
bits that are present in the original
Hmm.
n. That is
Hmm.
again equals to MSB, because
Hmm.
MSB is representing the number of set
Hmm.
bits, sorry, number of bits
Okay.
that are actually in the n.
Okay.
So this is the one line solution of the problem, a recursive solution. So what you have to do is to find a way to implement this one line solution. So just look at this one line solution until it is making a clear sense to you, and then we'll go ahead in solving the problem.
I have learned too much in this question because I have not done this
Yeah,
bits
yeah.
type questions earlier. That's why I'm finding difficulty in solving this question.
Usually these bit masking questions are of the immense depth, and that is why they
Yeah,
are difficult to
actually,
solve.
I have not done the questions in this range. That's why I'm not able to get the points easily.
But can I say now you get this problem? Hello, are you there? Hello?
So, could we just
You're not audible actually.
hello? Is
Yes,
I'm
yes. Now
audible?
you're audible.
Yeah, I was saying. So, can we avoid this question? Actually, I have not done bit masking questions.
Okay, okay,
Very, I
okay.
have done very less number of questions in the bit segment, and that's why I'm not able to get to the right approach. I think I need to study in this bit section more.
Okay, okay.
So, but
So
you,
can
yeah,
we at least say that you get the logic of this problem?
yeah, I got the logic. Surely, I have learned tons of things from this question, which I
Okay,
have still not learned in the bit section. So, thank you for that.
okay, okay. That's a good thing for me also, that
Yeah,
I get to
yeah,
teach you something.
yeah, yeah. And one thing more I get to know about myself is that my bit section is not that great. New
Yeah.
questions, if any new question comes from any part, then I am able to tackle that question. But this question,
Mhm.
I was completely wiped out. But how to deal
Okay.
with this thing?
That's the point of these DSA mock interviews,
Yeah, yeah, yeah.
to
It was
letting you know
completely
what.
worth it.
Yeah, yeah.
Yeah, yeah.
So can you provide us uh, some insights, that the overall overview of this interview that you have got?
So interview was great for me, not for the last question, but it was my mistake that I have not done this thing in my previous questions. But it was great experience, and the users which you are watching, please fill the form for this interview and just get a mock interview. Then you will get to know that what things you are getting wrong and in which topics you are weak and how to think in a real interview. Because solving a question in your room sitting alone is a easy task according to me, but in an interview I don't think it's a easy task to create logic and implement it, and to understand and to make understand interviewer also. So you should all try this thing.
Yeah, I
It's
agree
very,
with you.
yeah.
Yes. And
And I
now
have
I'll be
learned so
providing.
many things, and I came to know that I am not good at bits, and I have to do the questions of this thing.
Yeah,
I was not able to. Yeah.
that is very beneficiary to you.
Yeah.
So now I'll be providing some feedback from my side to you, the
Yeah,
things
sure.
that I think about you. So first of all, I have to mention that your resume is very, very good. You have done one internship, you have done several
Yes.
projects, and you have
Yes.
fabulously mentioned them, and you have briefly described each of them.
Yes.
So that is a very remarkable thing about you. And
Yes.
the second thing, your problem solving skill is very good. Yeah, I think uh, if we just provide you 4 to 5 minutes more in the second problem, then you would
Yes.
have easily done that also.
Yes.
And from my side, I'm telling you that I've
Yes.
uh, I've considered that to be done. Okay,
Mm.
from
But
my side,
actually, the
it is.
problem is I have not that strong basics in this bits. That's why I was going into
Yeah,
that uncomfortable zone. That's why I stopped this thing. But I just learned many new things about this bits, and I'll just surely try to implement this question after this interview.
yeah. And do you also solve the interview series problems?
Yeah, I solve interview series
Yeah, that's
problems
a really
and
good
the
thing.
jobathon also.
Yeah, because many
Yeah.
of the bit problems, bit
Yeah.
masking problems are
Yeah, yeah.
appearing there.
That's why I was confused, because the question which you just stated in the second question was a different question. But when I just got the
Yeah,
link, then I remembered that this question is a different one. Its
yeah,
approaches
yeah.
I
The
used bits like there, or the hash set there. So
Yeah,
initially
actually,
I
the
used
statement
the
of the
bits only.
problem was
Yeah,
changed
yeah,
because previous the problem was something else. But according to
yeah.
the test cases that we have generated in interview series, the
Mhm.
problem statement has to be changed, and that
Yes, yes.
problem has also been deflected today. So yeah,
Okay.
that's a normal thing.
Yes,
That's a daily thing for us.
yes, yes.
So I think you are a very good candidate, and I wish you very good luck for the future.
Thank you for this. Thank you.
Yeah. So everyone, please fill up the form
Yeah, it's
for
very
interview
important.
series.
Everyone should fill this form.
Because whenever you get to solve some problems in front of someone else that you don't
Yeah,
know, you have to face some challenges
yes,
that Mavan has also faced today. And after facing that, you get the urge to solve more and more problems and to improve yourself.
yes, yes.
Yeah, that's the point. So thank you everybody for joining the session. We'll meet you again in the next uh, mock interview series. Thank you, Mavan.
Okay. Thank you for interviewing me, and thank you guys for listening to me for this time.
Yes. So let's end the session.